Hello, everyone. Great to be back to RoachFest, second time. My name is Mahmoud. I'm a principal software engineer at Booking.com. We started using Cockroach about 3 years ago, and today I'd like to talk about our journey, how Cockroach is helping us, and some of the stuff that we learned along this journey. So I work on order platform, and I'd like to take you through, briefly, through what actually order platform does at Booking. So when you go to Booking.com and try to book your flight or book your hotel, order platform is the system responsible actually for making this happen. So it's a quite critical system for Booking. So the system basically is responsible for orchestrating different processes to make this booking happen. So we can go to initialize the payment, for example, so that you can start filling in your credit card details. It also can go to trigger the fulfillment process to make sure that we block the room for you. After this completes, the data stays in our platform, so it's basically the source of truth for reservation data for all of our customers. And things don't stop here because this is the most critical data now for Booking, so it goes to power many use cases. So when you go to your confirmation page, when you go to My Bookings page, or finance, for example, and machine learning systems need that data as well. So this system is quite critical, mission critical for Booking, and the data set is also of a high value. So we've been, the platform was established a few years ago, and we've been running quite well. We're doing 5 million writes a day, 2 billion read requests per day. We're quite resilient, we can scale. All of it is working fine. So what actually made us think that we need to change our database? So this is a high-level architecture of order platform. As you can see, once the request to create a new order or to change the order, the data lands in our primary storage, which is based on Cassandra. So after which, because the data is key, is stored as a key value, of course, we don't do more access patterns on through Cassandra, and we'll talk through this in short. We have to transfer the data to other systems as well. So we transfer the data through a Kafka topic that would through which we get the data to OpenSearch, so that we can retrieve the data using a user ID. We get the reservations for all of the reservations for a user. Or when a customer agent wants to look up a booking using an email address, for example. We also rely on this Kafka topic to push the data downstream, again, for other systems like finance, machine learning, and so forth to start using that. So given that setup, what kind of problems we started realizing here? First of all is the lack of asset transactions. So Cassandra doesn't provide the level of atomicity and isolation provided by according to the asset specs. So it kind of trades off atomicity and isolation for high performance writes and for high availability. However, we started realizing that this is kind of lacking in our application, and therefore in order to overcome these problems, we started relying on other features in Cassandra. Stuff like lightweight transactions, which we then learned the lesson the hard way that they don't really work well. So sometimes first of all, they are slow. They are quite expensive to run on Cassandra. Also, when they fail in funny ways, so they time out. But when they time out, you don't know if this timeout is a legit timeout, or is it because the conditions on the statement were not met. So we really don't know. So it complicated our application quite a lot. Second problem is that now we're storing the data, we're pushing the data into two data stores. There's no guarantee here that the data will be the same in both data stores. So in order to overcome that, in order to ensure that the data is the same, we had to implement another application that would basically cross-check the data is the same here. So it's another system that we have to keep maintaining. So maybe it didn't take us quite a lot of time to build that system, but we have to keep maintaining it and patching it as we go. Now, this is the third problem is retrieving using secondary indexes. And we're talking about here about 17 to 20 terabytes of data that we have to replicate from from Cassandra to OpenSearch. And this proved to be quite expensive for us. In order to build that system, in order to build OpenSearch and stabilize it with this amount of data and with the amount of workload that's introduced on it, we took like around a year to get it done. But also now the team has to keep maintaining that, and it's taking us quite a lot of time. And it's quite expensive as well. So to tell you a side story on OpenSearch. Before OpenSearch, we had a homegrown solution. And the homegrown solution was running on premises on like 1,000 machines. It's not Elasticsearch, not based on Elasticsearch. It's something that's totally homegrown. And management came to us saying, do something about it. This is quite expensive. So, okay, we're going to try something else. We moved to OpenSearch. They were not happy when they saw the bill. Yeah. So this has triggered us to kind of like rethink actually our architecture around that whole thing. So to summarize, now we have the pain points are like cost. It's quite expensive to move data around with that size. Time. So maybe the time to build some systems is doesn't take much time to build a system, but it will take a lot of time to troubleshoot that system, to keep maintaining the system, to patch it, and all of the headache that comes with productionizing a system. And of course, the cognitive load. So the most important thing here for the cognitive load is when systems become quite complex, it becomes really hard to change. So any change that we want to introduce, it takes longer time. It takes more discussions, more planning, and so forth. So we went on a journey to explore the whole database landscape, and we considered multiple solutions out there, and evaluated some of them through proof of concepts, which at the end we landed on Cockroach. So how Cockroach is helping us solve these problems. So this is the architecture without Cockroach, with Cassandra currently. This is the new architecture with Cockroach introduced. So what's changing? First of all, we have a simpler application. So now we don't have to care about, we don't have to complicate our application in order to overcome the lack of asset transactions, for example. So that's a big important thing for us. Second is now the CDC feature from Cockroach helps us to kill the Kafka topic stream, like copying data through a Kafka topic that we maintain on the application level, and all of the cross-checking that we have to maintain. So the change data capture is a huge feature for us that we are planning actually to use and depend on quite a lot in the future. So, and the most important thing is now we can reduce our footprint quite significantly on OpenSearch, because with the secondary indexes on Cockroach, we can actually most of our use cases are simple index lookups like user ID, get me the reservations for the past reservations in the last 10 days, for example. So quite simple lookups that we don't need a quite complicated system like OpenSearch to do it for us. So now we can keep OpenSearch for the things that Cockroach cannot make, like text search, for example. But it means that we don't have also to copy like the 17 or the 20 terabytes of data from to OpenSearch. So over this journey, we started learning some stuff. And not like everything was not like great. There were some learnings that we had to also adapt to. First realization was that the moving to Cockroach meant for us that we are trading availability for consistency. So the number on the left is the success rate of writes to Cassandra. The number on the right is the new success rate of writing to Cockroach. So you're seeing here that we are trading off like a couple of nines on the SLI here. And realizing, like, if we look at these numbers in isolation, we're not looking at the big picture. We cannot judge them as good versus bad. You know, say like, yeah, this was great, and now this is bad, because it's basically a cost. So we are incurring the cost for better consistency and simpler application logic. So is it acceptable? In our case, it was acceptable. Second learning is schema design. So when we started using Cockroach, it was like, okay, it's a PostgreSQL protocol. How about we start thinking about normalizing our data schema? Turned out not to be a great idea because it's yes, it's a PostgreSQL protocol, but under the hood, it's not a single master. It's quadly distributed, especially in our setup, which is using multiple single cluster that's a cross-region cluster in 3 regions. We are running in London, Ireland, and Frankfurt. So now the join goes across multiple regions. We overcame that by doing queries in parallel, but this also meant that we are now using more resources because it's not one request to get an order. Now it's like one request translated to many queries on the database. So now we have to use more resources on Cockroach. Now we are experimenting. We're still experimenting with ways of optimizing that. The first experiment we did was trying to use partitioning in Cockroach so that we can locate the data belonging to the same key across different tables into the same region. We saw some gains, but they were not significant for us. The biggest, the significant one was when we started merging tables. So when we merged the tables together, we started seeing benefits in latency and throughput. So we're still doing the experimentation, and hopefully, like before the end of this year, we will find that sweet spot. Now, so. We cannot talk about Cockroach without talking about resiliency. And so this picture, so I asked AI to generate this picture, but can anyone guess what it's about? Okay, I'll blame AI for that. So that's Barcelona during the last blackout. So I was there personally. I didn't have cash, so I wasn't able to buy anything. I wasn't able to navigate the city. It was a great experience. And I didn't even know what's going on. Like I found by accident that, hey, it's like whole Spain, whole Portugal, and parts of France. So it was great. So as case engineering says, and of course it's not caused by Cockroach. So this blackout is not because of Cockroach, by the way. So it's like this is a personal experience that I wanted to share. Yeah. So the question in case engineering, or case engineering has wisdom where things will always fail. The question is like when and how. So our wake-up call was this. We suddenly started seeing loss of nodes across all regions. So not a single region, it's across all regions. And this is like a big loss. Like we lost about 15 nodes of the cluster. So the root cause was identified that although Cockroach is a distributed database, there are single points of failure. And the single point of failure here was that the liveness nodes, the leaseholders that hold the nodes that hold the liveness range. When these nodes experience disk stalls, they kind of like fail to write this data, and therefore some of the nodes can be declared as not live, and therefore it impacted our SLOs quite significantly, both reads, writes, latency, success rates, everything. And this is not only the interesting part, because like we are used in Cockroach to nodes going down, leaving the cluster, joining again, during upgrades, like rolling restarts happen all the time. What was interesting about this is this particular thing. So now, if you look at this, this graph, so node 59 was actually the leaseholder of the liveness range. It started experiencing disk stalls. It moved, the liveness range moved to node 19 and started experiencing disk stalls. So now we end up with about 6 minutes of an outage. This is quite a lot for a mission-critical system like the OR platform here. So what we figured out, of course, there were some follow-ups afterwards. One thing that we, of course, we identified some gaps in our incident response. One of them was actually how we communicate with Cockroach. This kept happening for months. However, the business impact was not clear for Cockroach Labs. However, once that was made clear, Cockroach actually acted swiftly, and they implemented the wall failover, which is another if any node starts to experience disk slowness, they will just write to a secondary disk. So now, like things are going great. And since then, since this patch was enabled, we see things very stable. We also started realizing that, yes, we need to test our systems more. So now we're running join drills with Cockroach to simulate like the loss of some nodes, to see how our systems will respond, and as well test our incident response procedures. So finally, so our next, what would be our next challenges? So I think we talked about multiple things, cost, resiliency, and other stuff. We are trying to close a huge migration project that would actually, internally, that would actually 10x the load on our systems. And we need to make sure that when we do that, it's going to be cost efficient, so that we don't want to 10x of the load translates to 10x of the cost, because again, management will not be happy. We're also starting to see other teams within Booking trying to adopt Cockroach, so it would be another problem to solve, which is how to collaborate internally and how to organize our collaboration with Cockroach Labs in order to scale the adoption within the company. So the takeaways, first of all, the biggest lesson that we learned ourselves is like we have to understand, we should never underestimate the complexities within the databases. Anything that we say like, yeah, this is not something that we might not need, we can compensate for, it would actually translate into other complicated logic that we have to maintain or some expensive system that we have to build. Second thing is like, it's all about trade-offs. So we should not look at numbers in isolation. We have to look at the bigger picture and see what we're gaining versus the cost that we're having. And last thing, so anything will fail. So resiliency, we hear resiliency a lot. So, and resiliency isn't about never failing. It's actually about getting up fast, smarter with alerts. And I'm quite happy to see that Cockroach is building on stuff like physical replication, logical replication, online restore. Like all of these features are quite important for getting up fast. Lastly, like charity majors have really great quote, and I always like to quote her, like every outage is a dress rehearsal for the next one. So learn your lines. Thank you.